Hashing introduction. Hashing is an efficient searching technique. This hashing is used to place or map a large domain of key values into a specific location. Before I discuss in detail about the hashing technique, let me discuss why this hashing technique is exactly required. There are several searching techniques are there, like linear search, binary search, search trees, etc. But in these techniques, the time taken to search any particular element depends on the total number of elements, right? For example, if you take linear search, the worst case time complexity to perform searching operation is big O of n. And if you take binary search, the worst case time complexity is big O of log n time to perform the search in sorted arrays consisting of n number of elements. So minimum time taken by a searching algorithm to perform searching any data element in an array is going to be what? The binary search concept, right? But what is the drawback in these techniques? As the number of elements increases, the time taken to perform the search also increases with the linear search as well as with the binary search. This becomes problematic when the total number of elements become too large. Though it is log n, if n is large, it is going to take the time taken to perform the searching operation also would get increased, right? So these are the main drawbacks. So here, is it possible, is there a way to perform a search operation in time proportional to big O of n? Yes, it is possible. There is a way to search an array in constant time irrespective of its size with the help of the hashing technique. So mainly this hashing technique is used to search any particular element, any specific record from a large domain of record. So efficiently the searching operation can be performed with the hashing technique. And in hashing, we can easily perform insertion, deletion, updation and searching can be easily performed, and the location also can be calculated from the key value itself using a hash function. So here, with the help of the hashing technique, we are going to store the elements in a specific places with the help of the key value only. So here in the hashing technique, the addresses are generated from the key value itself. Suppose I want to store the data element to 240. To store the data element 240, the address location has been calculated from its key value only. So from its key value only, the address would be generated with the help of the hash function. So it is very easy to retrieve the record when it comes to searching so and so data element. It is very easy to perform the searching operation. Why? Because the address to store so and so key element has been extracted through the key value itself, right? So it is very easy to perform insertion, deletion. When it comes to updation of also, it is going to be very easy, and searching also can be done with a big O of 1 time complexity. So to perform any operation, it is going to take big O of 1 time complexity. Why? Because the address of the location of the key can be extracted from the key value itself with the help of the hash function. What exactly the hash function is? Hash function is nothing but the function which is used to transform the key of record into its physical address is known as the hash function. So some function, this hash function can be anything. There are n number of hash functions are there, and few hash functions would be discussed in the next video. So only with the help of the hash function only the address could be generated from the key value. So with the help of the hash function, the address, the location of the key value can be computed from the key value itself. So the hash function is nothing but the function which is used to transform the key into the physical address is what the hash function is. For example, if you take this key value, the key value 279, I just want to store it in the hash table, in the array, in an array I just want to store it. So if I want to store it, simple, with the help of the hash function. So this hash function can be anything, like any based on any condition this hash function could be generated. So this hash function is what going to generate the address for my key values. For example, for instance, the first bit of my key value is going to be the address location for so and so key value. Means if for example the element is 279, which means the first bit of the key value is going to be my address, which means at the address location, at its physical address to the hash, the so and so key element, the data element would get stored. The second key element is 468. The first bit is going to be my physical address, the key location, which means 468 would get stored in address location 4. And 569, first bit is 5, at address location 5, 569 would get stored, and 820 which means the first bit is 8 at address at physical location 8, 820 would get stored. So with the help of the hash function only, this address location has been generated as 2, 4, 5 and 8 for the given key elements. So this is what the hash function is. So only with the help of the hash function, the key value can be generated into the physical address, in which the key value can be stored over there. So the advantage here is the hashing is extremely efficient, and the time taken to perform the searching does not depend upon the total number of elements here. So irrespective of its input size, with the time complexity, constant time complexity of big O of 1, all the operations can be performed with the help of the hashing. So hashing is a well-known technique to search any particular element among several elements, and also it minimizes the number of comparisons while performing the searching operation here. That is a major advantage of hashing function here. And what exactly the hash table is? Hash table is nothing but array of some constant size in which a key value is placed in a specific location. This is the hash table. Hash table is used to hold the key values at a specific location. It's an array of some constant size is what the hash table is. And the hashing can be performed using an arrays only. When implementing a hash table using an arrays, the nodes are stored consecutively. Generally, consecutively in contiguous memory locations in an array, the elements would be stored, right? Instead, here in the hashing, the location of storage in an array is computed using the key and the hash function. So the computation of the array index can be visualized here. If you check here, if you check the computation of the array index has been visualized here. So here the key elements are not stored here consecutively in an array. Based on the key and the hash function, the address location has been generated in which the actual key we are supposed to store here. You check here, the array of size 9 is here, right? So there are 4 key elements I want to store inside the hash table, which means inside an array. I haven't stored the key element in the consecutive memory locations. Instead, I have computed the address locations index positions with the help of the hash function in which I have stored an array. Why? Because I want to perform an efficient operation when it comes to an insertion or deletion or searching, whatever it is. I just want to perform it with a big O of 1 time complexity, constant time complexity. This can be achieved only with the help of computing the hash function only. So with the help of the hash function, the address has been generated in which all the key elements has been stored. What is the need of hashing? To facilitate the direct access of records in file, the hashing is required, and also this hashing involves less key comparison and searching can be performed in a constant time. So the need of hashing is to perform direct access of record and also to perform searching in a constant amount of time. And next is hashing performance. The hashing performance can be influenced by 3 main factors. The performance of hashing can be influenced by 3 main factors. Number 1 is hash function. So here the hash function, whatever the hash function you prefer, as I told before, there are n number of hash functions there. So you have to prefer a hash function which distributes the keys and the entries evenly throughout the entire table, and also it should minimize the collision. Collision is nothing but if you assign the hash function assigns the same physical address for the 2 different key values, that is called the collision. Why? Because in each address location, only one key element can be stored. For example, I want to store 640 as well as 680. According to my hash function is extracting the address from the key value itself. The first bit of my key value itself is going to be my physical address, right, to store the key value. If I want to store these 2 key values, 640 and 680, first I want to store 640. According to, I'm just using the hash function to generate the address. If I use this hash function, it is going to generate the physical address 6. In the place of 6, I am storing the value 640. Again, Next, after storing the key element data element 640, I want to store the key value 680 as well. According to my hash function, the address location which it is going to generate again is going to be 6. But if I check 6, already I have stored the data element 640. So the 640 680 key value cannot be stored in the same address location. Why? Because for two different key values, if it generates the same address location, we call it as a collision. Why? Because in the same address location we cannot store two different key elements, two different data elements, that we call it as a collision. So when we prefer a hash function, it is mandatory that we are supposed to choose a hash function which distributes the key properly and it avoids the collision. That is number one factor. Second one is collision resolution strategy. There are two collision resolution strategies are there. One is open addressing and second one is separate chaining. When it comes to open addressing, it is nothing but it stores the key value, it stores the data element in a different position, in a scattered position. Second one is separate chaining. Means it chains several keys, suppose when we face a collision, which means for different keys, if you are getting the same physical address, means it would create a chain with the help of the linked list or any other data structure, a separate chain or key, like different the chain can be created and all the keys can be stored, all the entries can be stored in the same position with the help of the separate chaining method. And the third factor is table size. Table sizes also influences the performance of hashing. One is, if the table size is too large, wastage of memory would happen, right? That is also not required when the table size is too large. If the table size is too small, it may create increased collisions and eventually it would force rehashing. Rehashing in the sense creating new hash table of larger size and copying the content of the current hash table into it, which is very difficult, right, when it comes to rehashing. So if the table size is very small, it would create more collision. If there are more collisions, we are supposed to perform rehashing. Rehashing is nothing but creating a new hash table with a larger size and copying all the contents from the current hash table into a new hash table. And then also, if the size, so the size should be appropriate here to the hash function used, and typically it should be a prime number. You will understand why it should be a prime number, the table size should be a prime number later while discussing the further topics in hashing. So the principal criteria in deciding a hash function is the function, whatever the hash function you choose, that must be very easy and it must be quick to compute. It must not take, it must not be complex, and the hash function should not take several steps to compute its physical address. So the main criteria is it must be very easy and it must take only lesser number of steps to compute the physical address. And the second step is, the second principal criteria to decide the hash function is, the hash function h should uniformly distribute the key, because when you take the hash table, it must be uniformly distributed. It should not create a cluster. For example, if there is a hash table with a size 20, only first 10 are occupied and the remaining 10 are not occupied, which means first 10 cells alone has formed a cluster and the remaining hasn't formed, right? So if it forms a cluster in one particular places, again there are higher chances of getting the collision. So whichever the hash function you choose, it must be very easy, and also it should distribute the keys uniformly into the hash table, which means it should not give two different indices for two different it should not give same indices for two different key values, which means it must avoid collision and also it must avoid clustering also. Why? Because if there is a cluster formed in a hash table, the probability of getting collision is going to be high. So these two criteria you must keep in your mind while deciding the hash function. This hash function can be decided based on the size of the key values. If the size of the key values, for example, if the size of the input is huge, if you want to store huge collections of key values into the hash table, means you have to go with some other hash function. Suppose if the key elements are only lesser, the hash table size is also going to be very lesser. The chances of getting collision is also going to be lesser, right? In such case, you can prefer some other hash function. There are many different types of hash functions are there, which would be discussed in the next lecture. You have to prefer an appropriate hash function which suits for the nature of your the size of the input. Next is applications of hashing. First one is data integrity. Hash functions are used to verify the integrity of data. For instance, downloading a file and comparing its hash value with the provided hash value ensures the file has not been tampered with. So, to check the data integrity, these hash functions can be used, and also in security, cryptography. This hash function is essential in cryptographic protocols, digital signatures, and in many authentication mechanisms. This hash function is very important. Secure hash algorithms such as SHA algorithm, secure hash algorithms, message digest algorithms are commonly used. And the third application is for password storage. Passwords can be hashed before being stored in a databases. This ensures that even if the database is compromised, the actual passwords are not revealed. And the fourth one is for hash tables. Hashing is used in data structures like hash tables, where the hash value determines the index of the array where the data must be stored. This allows for efficient data retrieval, efficient data searching. And fifth application is checksum algorithms. Hash functions are used in creating checksums for error detection in during a data transmission. There are multiple hash functions are there in a cryptography, popular hash functions. As I discussed, one is SHA, that is secure hash algorithm, then MD5 algorithm, that is message digest algorithm. Then again in SHA itself there are versions, SHA-1, SHA-2, SHA-3. There are multiple popular hashing algorithms or their hashing functions are actually there. In the next video, different hash functions would be discussed to compute the physical address to store the key value. Thank you.